The previous lecture we were discussing about linear transformations, composition of linear transformations, and one bijective linear transformations and inverse of a linear transformation. I hope you got those concepts. If you have any question, you can answer. Today's topic is basically basis and dimension of a vector space, but before that, we need to discuss spanning set of vector space of vector space. Spanning set, and then we'll discuss basis of a vector space, basis of a vector space, and then dimensions of a vector space. So first of all, let us discuss the spanning set. Spanning set. In fact, a spanning set is a subset of a vector space containing finite many elements. For example, let us say that a set S, which contains the vectors v1, v2, so on, maybe k or n. And this set is a subset of some vector space V. So this set is a finite set. Okay? The span of S is the set of all linear combinations of vectors in S. Okay? Then the spanning set, or the span of S is the set of all linear combination, set of all possible, you can say, set of all possible linear combinations of elements of S, of vectors in S. Vectors in S. We have already discussed this this definition, but with the reference of unit vectors in Euclidean space. For example, if I say that V is R squared, and the set of unit vectors of R squared is what is E1, I told you earlier, E2, and this is what? It is 1, 0, 0, 1. Okay. Now this set, if we consider this set, it contains only the unit vectors of R2. Now, if we take the set of all linear combinations of these two elements, means if you consider that need to erase this. I hope you have read this definition. So, set of all linear combinations. Then the set of all linear combinations would be what? Combinations is what? It is a set which contains elements of this kind, maybe C1, E1 plus C2, E2. This is basically a linear combination, a general expression for the linear combination of these two standard elements, where C1 and C2, they belong to R. Now, can anyone tell me how many elements we can have by varying C and C1 and C2? How many elements? Anyone?
Sir, infinite many?
Yes, infinite many. If we take set of all possible linear combination of these two elements, E1 and E2, what do we get? Set of all possible linear combinations means here we have C1, 1, 0 plus C2, 0, 1. Okay, now you vary the values of C1 and C2, where C1 and C2 belongs to R. Can you imagine how many elements or what kind of space we will have by taking all possible unique combination of this kind. Anyone? Let me see who is there. Participants. Abdul Rafi, you tell me. Can you talk to me? No, he's not there. Hamza Irfan. No, you don't want to talk to me?
Sir, what's the question?
How many or what do we get if we take all the possible linear combinations of this kind? What we obtain?
Sir, the span of the set?
Again, for the first time, you put C2 is equal to 0. Okay. And vary C1 in R. What do you get? If you don't have this thing, you have only C1 into 1, 0. If you change the values of C1, what do you get? Graphically, can you put this thing on graph?
Stretch.
What do we get? Who was talking?
Stretch and so.
Bole? What do we get graphically? If we put C2 is equal to 0 and we change the value of C1 and we choose all possible values of C1 in R, what do we get?
Sir, x-axis?
Yes, x-axis. This one. Now, if we take only C2, we put C1 0 and we change the values of C2, what do we get?
The y-axis.
Y-axis. Yes, you are right. Now, till now we have either vary C1 or C2. Now, if we try to vary both C1 and C2, what do we get? Or only positive values of C1 and C2 in R. If we try to vary, if we try to choose C1 and C2, only positive values in R. What do we get?
Sir, vectors in the first quadrant.
We get the first quadrant. Okay? If we choose negative values of C1 and positive values of C2, if you vary them in R, what do we get? The second
quadrant.
Yes. And similarly, if we choose both negative values, we get third quadrant. And C positive, C1 positive, C2 negative, we get the fourth quadrant. This one. So, this expression surprisingly generates R2. Do you agree with me?
Yes, sir.
Anyone else who is not? Anyone else who is not? Agree with me. Now, I hope you get what is the meaning of spanning. Okay. Spanning means generation. Two elements of any particular vector space can generate a plane. For example, जैसे कि R2 में दो बेसिस वेक्टर्स हैं, स्टैंडर्ड यूनिट वेक्टर्स. अगर आप कोई एक ले लें तो वो क्या जनरेट करेगा? Either x axis or y axis. Means those two lines. अब अगर इन दोनों में आप देखें कि C1 और C2 they are basically belonging to R and we can change their values. How many linear combinations we can obtain if we change the values of C1 and C2 in R? They can generate, they can span R2. So this is what we call the spanning set. So the spanning set of R2 is what? Is this S set 1001. Similarly, you can imagine what could be the spanning set of R cube, who would generate R cube. Anyone tell me what would be the spanning set of R cube? It will be, of course, a set which contains standard bases of R cube. Okay? This is the spanning set of R cube, which exactly generates R cube. Now, if I say that I have this set as 1, and another I'm going to define this set as 2, which contains only 1, 0, 0, and 0, 1, 0. Now, this is the set. If I take the set of all linear combinations of these two elements, for example, C1, 1, 0, 0, plus C2, 0, 1, 0. Okay. Now, if we try to vary the values of C1 and C2, where C1 and C2 belongs to R, what do we get? If we try to take all the possible linear combinations of these two vectors, what shall I get? Anyone?
So the XY plane?
Yes, of course, XY plane, because the third dimension is 0. So in R cube, this unit vector 1, 0, 0, and this one 0, 1, 0, and this is 0, 0, 1. Okay. Now, only this vector is generating as x-axis if we only choose the linear combinations of this vector. Okay. This is generating only x-axis. If we choose C2 times 0, 1, 0, this is generating only y-axis. And the third one, C3 into 0, 0, 1, is generating z-axis. Okay, if I take these two vectors and take all the possible linear combinations of these two vectors, it will definitely generate xy plane, this one. This is your y, this is your x. So this is how vectors generate spaces and planes and any vector space. You have to imagine it. I hope you get the whole idea of a spanning set. If you have any confusion, you can ask me. Any question? Okay. If there's no question, let me ask you another question then.
Sir, I have a question. Sir, did the spanning set only have the E's or the E of them?
Did the spanning set has only what?
E1 and E2, E1
No.
and E2.
That's what I'm going to ask you now. Do we have any other set in R scale? For example, R scale. इसमें मैं दो elements ले रहा हूँ, maybe one and the other one is maybe 0, 1. Okay. Now, does this set can span R2? If we try to write the set of all linear combinations, which is C1 times 1, 1 plus C2 times 0, 1 is equal to, this one. If we take all the possible linear combination of these two vectors, do we still get the R2?
Sir, I don't think so.
Would they generate R2 or not?
Yes, sir.
Sir, I don't think so.
How can you know?
Sir, the 0.10 ये उसको generate नहीं कर सकता.
जरूरी नहीं है कि 1, 0 है. आप कुछ और ले लें यहाँ पे maybe 3 मान लें. It doesn't matter. Okay. Now we have these two vectors. Maybe -1 and 3 and 1, 1. Okay. What would be the graph of these two things? One vector will be 1, 1, and the other is -1, 3. So this is kind of this vector. Okay. It is 3, -1, and this one is 1, 1. Now, Would this set generate again R2? How can we know it? Now, here, if I say that this set is generating R cube, if I say that, if I claim this, if I claim that this set is generating R cube, what does it mean? It means every element of R cube can be written as a linear combination of these three vectors. I'm repeating it. If I claim that these three vectors are generating R cube, then every element of R cube can be written as a linear combination of these three vectors. So if we choose any element, any vector x belongs to R cube. Okay. So x किस टाइप का होगा? X होगा x1, x2, x3 या xyz. If I can prove that this vector can be written as a linear combination of these three vectors, what does it mean? This vector is in the set of all those possible linear combinations of these three vectors. Okay? So if I can write x as a linear combination of E1, E2, E3, then what does it mean? ये तो हमने एक जनरल एलिमेंट लिया ना, xy, x1, x2, x3 कोई भी एलिमेंट है. अब R3 का कोई भी एलिमेंट अगर इन तीनों वेक्टर्स के लीनियर कॉम्बिनेशन की फॉर्म में लिखा जा सकता है, तो इसका मतलब क्या है कि इन तीनों के जो लीनियर कॉम्बिनेशन है वो R क्यूब का कोई ना कोई एलिमेंट है. अगर हम सेट ऑफ ऑल पॉसिबल लीनियर कॉम्बिनेशंस यहाँ पे लेंगे इन तीनों के, तो आपके पास ये जनरल एलिमेंट है R क्यूब का. तो इसका मतलब क्या होगा कि इन तीनों के लीनियर कॉम्बिनेशन से आपके पास R क्यूब बन रहा है. R क्यूब इज जेनरेटिंग. सो अब हमने यहाँ पे क्या चेक करना है? इनफैक्ट इफ वी वांट टू नो whether these two vectors they are generating R cube.
Pakistan, there were 4 reasons mentioned that for a country to be a successful democratic state, it should fulfill the 4 criteria. First,
What is this happening?
And then,
Kindly mute your mic.
freedom of campaigning for the elections. Third one was that the defeating party should accept its defeat. And fourth one that whichever party won the elections, the complete party.
Muhammad Abdullah, what are you doing? So finally I have muted that guy. Thanks for this option. So now if I want to check whether I can generate R2 with the help of these two vectors, what should I do? I would try the same procedure. I would choose any general element of R2 and I will try to see whether I can write that vector as a linear combination of these two vectors. Okay. So what I'm going to do, choosing any vector x from R2, whereas x is what? It is x1 or x2 or xy, whatever you like. Now, I would try to check whether I can write any vector in R2 as a linear combination of these two vectors. Means any vector in R2, any element in R2 can be obtained from these two vectors or from the linear combination of these two vectors. So this is I have to check it. So let's try to do this. Now, I'm going to write x as a linear combination of this vector. For example, I call it v1 and this is v2. So I am going to write x as a linear combination of these two vectors. X equal to c1 v1 plus c2 v2. So x is what? x1, x2. is equal to C1, V1 is given 1, 1, plus C2 is given, V2 is given, it is 3 minus 1, this way. So now, what do we obtain here? Anyone? What is this? What is this?
Spanning set?
No. What is this?
Sir, an equation.
It's a non-homogeneous linear system. C1 plus 3C2 is equal to X1 and C1 plus minus C2 is equal to X2. You got this non-homogeneous linear system. Okay? Now, X1 and X2 are general elements of R2. What is unknown here? C1 and C2 are unknown here, which gives us the possibility of linear combination in order to obtain X1 and X2. Okay? So from this non-homogeneous linear system, we need to find C1 and C2. Okay. How do we do it? We write the augmented matrix. Augmented matrix क्या होगा यहाँ पे? It would be 1, 3, 1, negative 1, X1, X2. Okay? We do the same procedure for all kind of vectors in maybe R2, R3, R4, or any other vector space. We follow the same procedure. I just choose 2 by 2 vector just for my convenience in order to do it quickly, so that you can understand the concept. Now, after solving it, what do we get? Even we don't need to solve it. We just have to check whether this non-homogeneous linear system is consistent. We just have to check this. Then what do we conclude from here if we know that this non-homogeneous linear system is consistent? We know that we can write X1 and X2 as a linear combination of C1 and C2. Okay? We can write. If this non-homogeneous linear system has a solution, I mean, if it is consistent, then it would be true that we can write X1 and X2 as a linear combination of these two vectors. If we can write X1 and X2 as a linear combination of these two vectors, what does it mean? Means these two vectors are generating any element of R2. What does it mean? These two vectors spanning R2. I hope you get it. If you have any question, you can ask me. We can check whether this system is consistent or not. If this coefficient matrix of this non-homogeneous linear system is what? Is what? Anyone?
Non-singular.
It should be non-singular. ठीक है? अगर ये coefficient matrix non-singular है, coefficient matrix क्या है आपके पास? Coefficient matrix is A and it is 1, 3, 1, negative 1. इसका determinant क्या है आपके पास? क्या है? -4?
-4.
It is not 0. What does it mean? This non-homogeneous linear system is consistent. It has solution. What does it mean? We can write this element of R2 as a linear combination of these two vectors. What does it mean? Every element in R2 can be obtained by the linear combination of these two vectors. What does it mean? These two vectors are generating R2. Now, if we say that, let me draw it properly. So, अब हम ये कह रहे हैं कि यहाँ पे R2 जनरेट कर रहे थे दो वेक्टर्स 1, 0 और 0, 1, क्योंकि ये वाला वेक्टर जो है ये x एक्सिस को जनरेट कर रहा है और ये वाला वेक्टर y एक्सिस को जनरेट कर रहा है, और इन सारों के लीनियर कॉम्बिनेशंस जो हैं वो बाकी प्लेन्स को जनरेट कर सकते हैं. अब हमारे पास दो डिफरेंट वेक्टर्स हैं, ठीक है, एक 1, 1 है और दूसरा 3, -1. अब ये वेक्टर किसको जनरेट करेगा? ये वेक्टर किसे जनरेट करेगा? अगर हम सिर्फ सेट ऑफ ऑल लीनियर कॉम्बिनेशन ऑफ दिस वेक्टर लें तो क्या जनरेट होगा? C टाइम्स C1 times 1 1 set of all linear
So
combination. ये क्या
the
generate करेगा?
first and the third quadrant.
This straight line only. Okay, this factor will generate only this straight line.
Right.
आप इसको किसी भी एलिमेंट से, किसी भी रियल नंबर से मल्टीप्लाई करें तो ये उसी स्ट्रेट लाइन के ऊपर आएगा, क्योंकि स्केलिंग हो रही है ना वेक्टर की। जब आप पॉजिटिव कांस्टेंट्स लेंगे तो पॉजिटिव डायरेक्शन में स्केलिंग होगी, जब आप नेगेटिव कांस्टेंट लेंगे C1 को तो ऑपोजिट डायरेक्शन में स्केलिंग होगी, तो सिर्फ यही स्ट्रेट लाइन जनरेट होगी। ठीक है, अब ये वेक्टर जो है ये किसको जनरेट करेगा? 3 - 1, ये सिर्फ इस स्ट्रेट लाइन को जनरेट करेगा, इसको। ठीक है, दरमियान में से इन ये जो स्टैंडर्ड यूनिट वेक्टर्स वाली लाइन है इनको मिटा दें। अब आपके पास ये दो स्ट्रेट लाइंस आ गई which are corresponding to these two straight lines x axis and y axis। अब वेक्टर्स तो डिफरेंट है ना आपके पास। अब अगर हम इनके सारों के लीनियर कॉम्बिनेशंस लेंगे, मीन C1, हाँ ये वाला एक्सप्रेशन है, इसमें C1 और C2 दोनों को वेरी करेंगे तो कौन सा, अगर पॉजिटिव लेंगे तो कौन सा क्या जनरेट होगा? ये वाला क्वाड्रेंट। उसी तरह अगर एक किसी को नेगेटिव पॉजिटिव करेंगे तो ये वाला, फिर ये वाला और ये वाला प्लेन जनरेट होगा। ये आपके पास एक और R2 जनरेट होगा, but this R2 is different from that standard R2. This is your standard R2 with the basis vectors, with the spanning vectors 0 1 and 1 0. इस R2 को कौन क्या जनरेट कर रहा है? इस R2 को जनरेट कर रहा है 1 0 और 0 1, which is a standard R2. ठीक है, इस R2 को कौन जनरेट कर रहा है? ये वाले दो वेक्टर्स 1 1 and 3 - 1, and this is again you obtain R2, but this is not a standard R2, this is a different R2. वो वाला R2 जो है इसमें जो स्ट्रेट लाइंस हैं, they are mutually perpendicular because they are mutually perpendicular unit vectors. अब ये वाले वेक्टर्स mutually perpendicular नहीं, they are just the vectors, non-perpendicular. इससे भी आपके पास R2 जनरेट हो रहा है। So this R2 is not the standard R2, this is some other R2, but it's exactly like that, the previous R2. Not in that sense कि perpendicular lines उसकी जो है ना वो unit vectors जो है वो उनसे जनरेट हो रहा है, ये unit vector से जनरेट नहीं हो रहा है। This is something different. I hope you get it. If you have any question, you can ask.
So the practical terms में standard और non-standard में फर्क क्या है फिर?
हाँ, that's a good question. We'll discuss it. ठीक है, it means you can generate R2 not only with the standard unit vectors, there might other possibilities to generate R2 with some other vectors. ठीक है, for now you remember this. You got this concept? Anyone? Similarly, we can generate R cube by a finite set of vectors, maybe V1, V2, V3, V4, V5. और ये जरूरी नहीं भी है कि आपके पास दो वेक्टर्स हो। You can have 3 vectors as well. 3 वेक्टर्स जो हैं वो R cube को, R square को भी जनरेट कर सकते हैं, but not less than 2. क्योंकि एक वेक्टर लेंगे तो वो R2 को जनरेट नहीं करेगा, वो एक स्ट्रेट लाइन को जनरेट करेगा। ठीक है, जब आप 3 वेक्टर्स लेंगे तो जो तीसरा वेक्टर होगा वो आई होप बाकी दोनों वेक्टर्स का लीनियर कॉम्बिनेशन होगा, वो इतना कंट्रीब्यूट नहीं करेगा आर स्क्वायर को जनरेट करने में। ठीक है, वो स्टिल वो उसके क्या होगा, लीनियर कॉम्बिनेशन के अंदर होगा। ठीक है, सो If you have any question, you can ask. वैसे भी R2 में सॉरी Rn में यूक्लिडियन स्पेसेस में अगर आपके पास this is a theorem which you should know, at least its statement that इसका प्रूफ जो है वो बुक में होगा, आप देखिएगा ये थ्योरम भी है बुक में। अगर आपके पास Rn है, Rn और n इसकी क्या है डायमेंशन है, you know this kind of dimension. We will discuss dimension in detail later on. अगर कोई सेट S है, इसमें वेक्टर्स हैं v1, v2, so on, dk, such that अगर k less than n है, अगर k less than n है, तो ये सेट Rn को जनरेट नहीं कर सकता। जैसे कि मैंने अभी एग्जांपल दिया आपको, R अगर R2 है, तो R2 में अब बस एक वेक्टर जो है वो R2 को जनरेट नहीं कर सकता, वो उसके सबसेट मींस उस एक स्ट्रेट लाइन को जनरेट करेगा। लेकिन अगर k ग्रेटर देन और इक्वल टू n है, तो फिर ये S सेट जो है Rn को जनरेट कर सकता है, मींस स्पैन कर सकता है। ठीक है, सो लुक एट दिस थ्योरम, you would definitely understand this. If you have any question, you can ask.
So ये k क्या था? What was
K is
k?
the number of factors. Number of
Same
factors.
thing.
ठीक है? Means अगर आपके पास R cube है, ठीक है? तो कोई से दो वेक्टर्स मींस 1 1 1 maybe and 3 3 2 -1, कोई से तीन अगर दो वेक्टर्स, तो ये कभी भी R2 को जनरेट नहीं कर सकते। ये R2 के अंदर एक प्लेन को या एक स्ट्रेट लाइन को जनरेट करें। इट डिपेंड्स के ये दोनों पॉइंट्स इंडिपेंडेंट हैं, लीनियरली इंडिपेंडेंट हैं। अगर ये दोनों लीनियरली इंडिपेंडेंट हैं, तो ये एक प्लेन को जनरेट करें R2 के अंदर। ठीक है, अगर ये एक दूसरे पे डिपेंड कर रहे हैं, तो फिर एक दूसरे का लीनियर कॉम्बिनेशन होगा, मींस एक ही वेक्टर होगा आपके पास, तो वो फिर एक स्ट्रेट लाइन को जनरेट करेगा। ठीक है,
जी ठीक।
the other point should not be on the same line. Okay, the other point should not be in the linear combination of the first point. Then it will generate plane. Otherwise, it will generate a straight line. I hope you get it. This concept of spanning. If you have any question, you can ask.
सर अगर ग्रेटर हो तब कैसे करेगा? क्योंकि जो मैट्रिक्स अगर जैसे फॉर एग्जांपल R2 हो और अगर तीन पे वेक्टर स्पैन कर रहे हो, तो जो मैट्रिक्स बनेगा उसका डिटरमिनेंट कैसे निकाल सकते हैं?
मसलन आप ये देखिए, फिर आपके पास डिटरमिनेंट नहीं होगा ना, यू हैव टू सॉल्व दैट non-homogeneous linear system. Okay, and you have to check whether this non-homogeneous linear system has a solution or not, if it is consistent or not. Well, for example, आप दो यूनिट वेक्टर्स ले लें, ठीक है, और तीसरा कोई एक यूनिट कोई वेक्टर ले लें 3 5, अब ये भी R2 को जनरेट करेगा। ठीक है, आपने चेक करना है ना कि ये स्पैन करता है R2 को या नहीं। क्या करेंगे, हम कोई भी एलिमेंट लेंगे x1 x2, we'll try to write this general element as a linear combination of these three vectors, 1 0 plus c2 0 1 plus c3 3 5. Now you get a non-homogeneous linear system, means c1 plus 3c3 is equal to x1 and c2 plus 5c3 is equal to x2. Okay, you get this non-homogeneous linear system. You try to solve it now. Okay, you would see that कि c3 की वैल्यू 0 आ जाएगी। c3 की वैल्यू 0 क्यों आएगी? क्योंकि ये वेक्टर जो है वो इन दो वेक्टर्स का लीनियर कॉम्बिनेशन है या नहीं? अब मैं आपको बताता हूं कि ये c3 क्यों रिडंडेंट है ये वेक्टर। अगर आप इसको यूं लिखें c3, ये जो है इसको बेसिकली हम कैसे लिख सकते हैं, 3 times 1 0 plus 5 times 0 1 लिख सकते हैं ना। मींस ये वेक्टर जो है वो इन दोनों का लीनियर कॉम्बिनेशन है, वही हमने लिखा। ठीक है, अब अगर इसको 3 से मल्टीप्लाई करें, 3c3 और 5c3 टाइम्स दिस, तो आप यहां से इस वेक्टर में से और इस वेक्टर में से कॉमन ले सकते हैं। क्या कॉमन ले सकते हैं आप यहां से? आप c1 प्लस 3c3 कॉमन ले लें, आपके पास पहले वाला वेक्टर आएगा, प्लस दूसरे में से आप क्या ले लें, c2 प्लस 5c2 टाइम्स 5c3 टाइम्स 0 1। अब ये c1 प्लस c3, इसको आप कोई और कांस्टेंट क्या दें, अल्फा 1 1 0 प्लस इसको आप अल्फा 2 कह दें, अल्फा 2 टाइम्स 0 1। इनफैक्ट आपके पास जो R2 को जनरेट कर रहे हैं वो यही दो वेक्टर्स कर रहे हैं, ये वेक्टर रिडंडेंट है आपके पास। I hope you get it. If this vector can be written as a linear combination of these two vectors, then this vector is redundant. It doesn't play any role in spanning R2. I hope you get it. You got it? Who asked me this question?
जी सर।
ठीक है, कोई और क्वेश्चन है तो you can ask me. Still, that non-homogeneous linear system would have a solution for C1 and C2 non-zero, and C3 would be 0. So that's why I had written there for k greater than or equal to 1, that set S can span Rn. But if k is less than n, then the set cannot generate that Rn corresponding. Now, let's come back to now spanning set में कोई issue है? If you have any issue, you can ask me any question. Now we are going to discuss the basis of a set, basis of a vector space. So, basis of a vector space. Basis, in fact, basis set. You can say here that basis set. Let S is equal to wahi V1, V2, so on, V maybe N or K, whatever you like, Vk is a subset of some vector space V. Then S is called basis set of V if the following two conditions are satisfied. S means you get it. V is equal to span of S. Span of S. Means V can be generated by this set S. Means S का जो spanning set है वो V है. S V को generate कर. दूसरा क्या है? S is linearly independent. Independent set. What does it mean? S के जो vectors हैं, they are linearly independent. अभी मैंने जो previously example दी थी आपको तीन vectors की R2 में हमने consider किया था V हमने R2 को लिया था और S set हमने लिया था 1 0 0 1 and 3 5. अब ये S set जो है ये दोनों कंडीशन को सेटिस्फाई नहीं कर रहा, पहली कंडीशन को सेटिस्फाई कर रहा है. This set is spanning V, is generating V, but this set is not linearly independent. क्यों? क्योंकि इसमें ये तीनों वेक्टर्स हैं वो म्यूचुअली linearly independent नहीं है. They should be linearly independent. क्यों नहीं है? हमने देखा था कि ये एलिमेंट जो है वो इन दोनों का लीनियर कॉम्बिनेशन है. So this set is not linearly independent. What does it mean? This S set is not a basis set for R scale. This set S is not a basis for R2. अगर ये S1 है, for example, S2 define करें 1 0 and 0 1. अब ये सेट जो है S2 ये R2 को स्पेन कर रहा है। S2 स्पेनिंग R2, पहली कंडीशन ट्रू है, हमने पहले देखा था कि ये स्पेन कर रहा है क्योंकि every element in R2 can be written as a linear combination of these two vectors. Second thing, does this set S2 is linearly independent? Anyone? Anyone?
Yes, sir.
This set is linearly independent. Its vectors are not dependent on each other. They cannot be obtained as a linear combination of other vectors. They are totally independent. So this set S2 is linearly independent. Okay? What does it mean? This S2 is the basis set for R2. Okay? S2, which is 1, 0, 0, 1, is a basis set. The basis set of R2. Yes. Okay, what is the basis set? Basis set is that set which spans, which generates that vector space, as well as the set of vectors or elements in that set, they must be linearly independent. Okay. If you have any question, you can ask. Now let me tell you one quick definition related to the basis, and then we'll come back to basis, how to check whether a given set is a basis or not completely. So one more definition which I wanted to tell you, dimension of a vector space. Dimension of a vector space. What is the dimension of a vector space? It is the number of elements in the basis set of a vector space. Number of elements, it's what? Number of elements or vectors, you can say. Number of elements or vectors in the basis set. In the basis set is called the dimension of a vector space. Okay? So, अब अगर S2 basis है R2 की, तो इसमें कितने elements हैं? How many elements are there? Anyone? 2. What is the dimension of R2? 2.
2.
इसीलिए हम इसको 2 डायमेंशनल कहते हैं. ठीक है? R3 का जो बेसिस सेट है उसमें कितने एलिमेंट्स होंगे? 3. इसीलिए उसको 3 डायमेंशनल स्पेस कहा जाता है. ठीक है? क्योंकि उसकी डायमेंशन 3 होती है. उसके बेसिस सेट में मिनिमम एंड मैक्सिमम बोथ एग्जैक्टली 3 एलिमेंट्स होने चाहिए. 3 वेक्टर्स. R³ की जितनी भी बेसिस सेट्स होंगी उसमें सिर्फ और सिर्फ 3 एलिमेंट्स हो सकते हैं, ना 3 से ज्यादा ना 3 से कम. अगर 3 से कम होंगे तो क्या होगा? वो R³ को जनरेट नहीं करेगा, वो R³ के अंदर किसी प्लेन को जनरेट करेगा. अगर 3 वेक्टर्स से ज्यादा वेक्टर्स होंगे तो जो चौथा वेक्टर होगा वो पहले 3 या कोई से 3 एक वेक्टर जो है वो किसी दूसरे 3 वेक्टर्स का लीनियर कॉम्बिनेशन होगा. मींस एक वेक्टर उसमें रिडंडेंट होगा. स्पेन कर सकता है एस सेट, 4 वेक्टर्स के साथ एक सेट R³ को जनरेट कर सकता है, लेकिन वो लीनियरली इंडिपेंडेंट नहीं हो सकता. मींस वो बेसिस सेट नहीं बना सकता. R³ के कोई से 4 एलिमेंट लें, वो सेट कभी भी लीनियरली इंडिपेंडेंट नहीं होगा. I hope you get it. If you have any question, you can ask me. Think over it. I'll give you 15 seconds to think about these concepts, and if you have any question, you can ask.
Sir,
जी.
बेसिस सेट का यूनिक होना तो जरूरी नहीं है ना?
यूनिक नहीं होना जरूरी है. Basis set can contain any other 3 elements. आपके जो स्टैंडर्ड R2 है, स्टैंडर्ड R2 है, उसका जो बेसिस सेट है वो क्या होगा? स्टैंडर्ड R2 का वो 1001 होगा। लेकिन जो नॉन स्टैंडर्ड R2 है उसका बेसिस सेट 1001 नहीं होगा, उसका वो दूसरा होगा जो अभी हमने जिससे R2 दो डिफरेंट वेक्टर से भी बनाया था ना, तो उसका जो बेसिस सेट होगा वो दो वेक्टर्स होंगे जो उसको जनरेट करेंगे और लीनियरली इंडिपेंडेंट होंगे। So basis set cannot be unique. Basis set can be infinite many. R2 can have infinite many basis sets. But the number of elements in that basis set in R2 should be unique. There should be only 2 elements.
Yes, sir.
Okay? Any other question? But this is the case only in Euclidean spaces. Remember this. Rn, R3, R4, R2 के बेसिस सेट में सिर्फ 2 एलिमेंट्स हो सकते हैं। 2 से ज्यादा करेंगे तो बेसिस नहीं होंगी। स्पैनिंग हो सकता है लेकिन इंडिपेंडेंट नहीं हो सकता। लेकिन if we are not working in Euclidean vector spaces, for example, we are working in polynomial spaces, matrix spaces, then the basis set could be different. The number of elements in the basis set need not to be equal to some other specification of the vector space. जैसे यहाँ पे R3 है तो basis set में 3 elements होने चाहिए, R4 है तो 4 elements होने चाहिए। लेकिन अगर आप matrices 2 by 2 के अगर set of matrices है तो उसमें मेरे ख्याल में basis set में 4 matrices होंगे मेरे ख्याल में। Let me tell you about some other vector spaces या polynomial spaces अगर आप लेंगे। अगर हम लेते हैं M2 set, which is the set of all 2 cross 2 matrices, तो इसका जो basis set होगा वो क्या होगा? It's quite natural. Can anyone tell me what would be the basis set of this set M2?
Sir, 1 or फिर 3 zeros different order में?
0 0 0 yes, 0 1 0 yes, and 0 0 1 0 and 0 0 0 1. Okay, this is the standard basis. There could be any other combination of 4 matrices which could be the basis set of this M2 set. But this is the basis set, standard basis set for this M2. Okay. If you change the dimension here, maybe M2 cross 3 is a set of all 2 cross 3 matrices. So you can expand this thing over the 2 cross 3 matrices. The dimensions, the standard dimensions. वो क्या होंगी? As you guessed here, 1 0, this one, and 0 1 0 0 0 0, and so on. You just track the 6 matrices here with each entry 1. Okay. All others 0. So these are standard bases. Similarly, in the set of polynomials, for example, we have a polynomial of degree, a space of polynomials. This Pn of x, such that Pn of x is a polynomial of degree less than or equal to n. Pn of x is a polynomial of degree less than or equal to n. So then its basis set would be what? Anyone? Which set will generate a polynomial of degree less than or equal to n? The basis set for this polynomial is what? 1, x, x squared, so on, x. And this will be the basis set for polynomial of degree less than or equal to n. इसमें आपके पास कितने वेक्टर्स हैं? कितने एलिमेंट्स हैं?
N.
No.
n plus 1.
N plus 1. So the dimension of Pn of x is what? N plus 1. Okay. Similarly, there are many other spaces whose basis set you can compute. Just you have to you have to check whether the set generates that vector space, and the second thing you need to check is whether the elements of that set are linearly independent or not. I hope you can do it. You just have to follow the same procedure while applying those concepts of spanning and linearly independent on these sets. अब आपने अगर इसको बेसिस सेट प्रूफ करना है तो आप क्या करेंगे, कोई एक जनरल एलिमेंट लेंगे M2 क्रॉस 3 में से. जनरल एलिमेंट क्या होगा? फॉर एग्जांपल हम लेते हैं कोई जनरल एलिमेंट है मे बी A1, A2, A3, A4, A5 and A6. अब हमने ये प्रूफ करना है कि ये जो मैट्रिक्स है ये this can be written as a linear combination of all these 6 vectors. Okay, then we would say that these 6 vectors, these 6 matrices, in fact, they generate any element of M2 cross 3. What does it mean? These elements, these matrices generate M2 cross 3. And then, similarly, we have to prove whether these 6 matrices, they are linearly independent or not. And in order to check whether they are linearly independent, I hope you know how to check it. If you have any confusion, you can ask me. You just have to put them as a linear combination C1 times 1 0 0 0 0 0 plus C2 times 0 1 0 0 0 0 and plus so on plus last one C6 0 0 0 0 0 1 is equal to the null matrix 0 0 0 0 0. So this you need to solve this thing. If you get all the constants equal to 0, then these matrices will be linearly dependent. ठीक है? अच्छा, स्पेलिंग कैसे चेक करेंगे? You have to check whether this A can be written as this must be equal to this linear combination. You don't need to put it equal to 0. Now you choose any general element and you try to check whether we can write this element as a linear combination of C1 first matrix, C2 second matrix, and so on, C6 last matrix. This. अब यहाँ से आपके पास एक system of linear equations आएगा. How do you get the system of linear equations from here? You just multiply the C1, C2, C6 inside. You compare the respective entries of the both matrices on both sides. You get the system of linear equations, non-homogeneous. You get the non-homogeneous linear systems, then you have to check whether that system of non-homogeneous linear system it is consistent or not. Okay. Now, in this case, you do not get the square matrix, coefficient matrix. You cannot just check the consistency of linear system by only verifying the determinant of a matrix, because it's a non-square matrix. It's a rectangular matrix. So rectangular matrix का determinant तो नहीं आएगा. Then you have to properly solve that non-homogeneous linear system in order to check whether the given linear system is consistent or not. If that linear system is consistent, we can say that any matrix of this kind in 2 cross 3 can be written as a linear combination of all these vectors in S set. What does it mean? These vectors generate M2 cross 3. Means these vectors spans M2 cross 3. And if they are linearly independent, then this set would definitely form the basis set of M2 cross 3. I hope you get it. If you have any question, you can ask me. And the dimension of this matrix 2 cross 3 space, it is a vector space. What would be its dimension? Its dimension will be the number of elements in its basis set, which is 6. So its dimension is 6. Any question? Think over it. I'll give you 15 to 30 seconds to think over these concepts, and then you can ask me any question if you have.
जरा आप रिपीट कर सकते हैं कि ये 6 डायमेंशंस कैसे हुई? वो जरा मुझे समझ नहीं आई।
6 एलिमेंट्स होंगे
6 कैसे डायमेंशन? जी।
कितने एलिमेंट्स होंगे इसमें? You tell me.
सर इस पूरे सेट में ये तो सर 2 है।
क्या?
एलिमेंट्स
हाँ, ये कितने मैट्रिसेस हैं इस सेट में?
2 सर 2 है।
सो ऑन किया हुआ था आपने, बाकी खुद लिख रहे थे। बाकी और कितने होंगे इसमें? I need to write 0 0 1 0 0 0 and 0 0 0 1 0 0 and 0 0 0 0 1 0 and 0 0 0 0 0 1. Now कितने एलिमेंट्स है? ये कंप्लीट सेट हो गया।
6 है सर।
6 है ना? तो यही बेसिस है उसकी। ये अभी हमने इसको इस सेट को प्रूफ किया है कि ये बेसिस है। मैंने यहाँ पे कहा था C1 टाइम फर्स्ट एलिमेंट, C2 टाइम सेकंड एलिमेंट एंड सो ऑन, प्लस C6 टाइम द सिक्स्थ एलिमेंट जो मैंने यहाँ पे लिखा।
ठीक सही।
तो इस सेट में 6 एलिमेंट्स है तो उसकी डायमेंशन 6 होगी ना? मींस 2 क्रॉस 3। You got it? Any other question? So this was all about the basis, spanning set, basis set, and dimension of a vector space, especially in the Euclidean vector space.
Sir,
जी,
dimensions की graphical representation होती है?
Yes, in the case of only Euclidean vector spaces, R2 key, R3 key. But in the case of matrices, how do you display or how do you show the dimension of the vector space of matrices 2 or 3? It's not possible. It could be a table having 2 rows and 3 columns. Okay? A matrix could be a table having 2 rows and 3 columns in this case. Okay, so
Yes, sir.
you can look at that table having 2 rows and 3 columns, and by skipping the entries of that table, you can imagine that is the dimension of this space.
Sir, polynomials को तो हम 2D space में plot करते हैं.
That is something different. Polynomials को 2D space में, it depends. देखिए, आपका polynomial of degree 3 भी 2D space में प्लॉट हो रहा है, polynomial of degree 10 भी 2D space में ही प्लॉट हो रहा है, लेकिन polynomial of degree 10 जो है less or equal to 10, उसकी dimension 10 है, and still you are trying to plot it in R2. So that doesn't make any sense कि एक ऐसा सेट जिसकी dimension 10 है वो R2 में प्लॉट हो रहा है, लेकिन in fact अगर हम उसको वेक्टर स्पेस कंसीडर करें तो उसकी dimension क्या होगी? 11.
N plus 1.
You got me. Polynomial of degree less or equal to 10 है तो उसकी dimension 11 होगी ना, and
Yes,
still you can plot it, you can show it in R2. It depends on the
Yes, sir.
function. So it doesn't
Right.
make any sense कि vector spaces की जो dimension है they are entirely different. This is basically an abstract kind of concept. R2, R3 में आप dimensions को display कर सकते हैं, या up to some extent R10, R50 maybe you can imagine what kind of dimension it would be. But in set of polynomials and in the set of matrices, it is very difficult to imagine the dimension vectors or the directions, their directions. It is not possible to imagine it. Okay?
Right.
Okay, any other question? No, if there are no questions, let me start with another important concept which is closely related to these spaces. Now we are going back towards the linear system and matrices. We will relate all these concepts with the linear system. Now we are going to define the column spaces and row spaces of a matrix. Row space and column space and null space. These are the most important spaces. In order to discuss these things, we had to define all those vector spaces and subspaces, linear independence, spanning, dimension, basis. All those things are basically applicable here in these things. Now we are going back toward the linear systems in order to relate all this stuff which we have discussed in the previous few lectures. We are going to relate all those concepts to the linear systems again. So column space, if you have any matrix, okay, it has order m by n maybe. It's a matrix of having rows m and columns n. इसमें कितनी rows होंगी? m rows होंगी. Or columns, n columns होंगी. So a space, in fact a vector space, a space which is generated by only the rows of a matrix is called a row space. Again, कोई भी matrix है आपके पास, अगर फर्स्ट करें इसको हम लिख लेते हैं A11, A12, so on, A1n, A21, A22, so on, A2n, and so on and so on and so on, an1, an2, so on, an. इसमें कितनी rows होंगी? इसको अगर हम row 1 कह दें, it's a vector. Remember, row 1 vector is what? It is A11, A12, so on, A1n. This is the row 1. इसको आप row 2 कह दें. So this is your row 2, 2, 1, 2, 2, so on, 2n. This is your row 2. Okay? And how many rows do we have here? Rm. M rows होंगी. तो last वाली row क्या होगी? Am1, Am2, so on, Amn. ये रहे. अब इसी तरह columns को अगर हम denote करें, इसको हम column 1 कहें. This one. ये column 1 है. ये किसके equal होगा basically? A11, A21, so on, Am1. अच्छा, columns की dimension क्या है? इसमें कितनी entries हैं? M. So columns की dimension क्या है? M. Column 2 क्या होगा? This is your column 2. It contains A12, A22, and so on, Am2. अब column आखिर में so on, last column क्या होगा? C. N. अच्छा, columns, number of columns कितने होंगे? N. हर column vector की dimension क्या होगी? Anyone?
So
Dimension क्या होगी? कितने elements हैं इसमें? M.
M elements.
So, M. So ये जो column vectors होंगे, उनकी dimension M होगी. ठीक है? और number of columns जो हैं, वो क्या होगा? For example, C से denote करते हैं, तो columns कितने होंगे? N. C1, C2, so on, Cn. इतने columns होंगे. N columns होंगे, लेकिन ये subspace किसकी होगी? ये होगी R. Subset किसका होगा? Rm का. Remember this. इसी तरह आपके पास rows की dimension क्या है? This belongs to Rn. But अगर हम rows का set लिखें अगर, तो इसमें vectors कितने होंगे? M. Remember this. R1, R2, so on, Rm. ये होगा, और ये subset किसका होगा? ये होगा subset Rn का. क्योंकि हर vector जो है, row vector, उसकी dimension n है. उसमें n entries हैं. So remember these things. Now, if this is basically the set of all row vectors NA। अब अगर R से जो जनरेट होगी स्पेस, R से जो स्पेस जनरेट होगी, R से जो स्पेन ऑफ R होगा, स्पेन ऑफ R, ये किसका सबसेट होगा? Means set of all linear combination of these row vectors will give us a space, and that space will be a subspace of what? Of Rn, because we are choosing the vectors from Rn. So remember this. Similarly, C जो span करेगा space, span of C जो होगा means set of all columns of a matrix. इससे जो space generate होगी वो किसकी subspace होगी? इसकी. Subspace of subset of means Rm, which is the number of rows. Columns जो space generate करेंगे वो R power rows, number of rows dimension होंगी उसकी subspace. जो columns, sorry, जो rows जो space generate करेंगे, set of all linear combination of these row vectors will generate a space, and that space will be a subspace of number of R power number of columns. Remember this. Don't confuse yourself with these dimensions. अच्छा, ये जो space generate करेंगे span of R, इससे जो भी space आएगी means अगर हम इसको H कह दें, ठीक है, तो ये H जो है इसको हम row space कहेंगे. This H will be called row space. और इससे जो space generate होगी इसको maybe H1 कह दें, इसको आप H2 कह दें, ठीक है. Column vectors से जो space generate होगी उसको हम column space कहेंगे. So these are two famous subspaces, row space and column space, which is generated by the rows of a matrix and columns of a matrix. And clearly, carefully, you have to see कि आपके पास जो H1 है ये किसकी सबस्पेस है और H2 है ये किसकी सबस्पेस है. मसलन अगर यहाँ पे हम मैट्रिक्स लेते हैं maybe 1 2 3 4 5 6, अब इसमें जो रो स्पेस होगी वो किसकी सबस्पेस होगी? Anyone? रो स्पेस हम कहते हैं कि H1 जो है वो रो स्पेस है और ये जनरेट हुई है रोज से, ठीक है. रोज कितनी है? It is basically the set of rows, row vectors. Set of row vectors से H1 जनरेट हुआ है, तो ये जो H1 है ये किसके सबस्पेस होगी? Tell me, anyone? Nobody's there?
Sir, R2?
Yes, R2. क्यों? क्योंकि ये R सेट क्या है? ये सेट है 1 2 रो 1 रो 2 एंड रो 3. ये R2 ये सेट है, इसमें 3 वेक्टर्स हैं लेकिन तीनों वेक्टर्स की डायमेंशन क्या है? 2. तो ये सबस्पेस होनी चाहिए R2, ठीक है. और H2 जो subspace है which is generated by the column vectors, and the column vectors is what? It has 2 vectors, 1 3 5 and the other one is 2 4 6. So it has 2 columns but every column vector has dimension 3. So this space should be the subspace of R3. Do not confuse it, okay? Any question? We'll discuss these spaces in more detail in the next lecture. We'll also define the null space. Null space पहले मैंने आपको I think पहले थोड़ा सा इसको basic definition बताई थी. We'll discuss this with the help of more results and theorems in the next lecture. Null space is the space is basically it contains set of all solutions of a homogeneous linear system. Do you remember we defined the kernel of any linear transformation? Kernel of any linear transformation was what? It is in fact the null space of any matrix. Any coefficient matrix which is basically the coefficient matrix of the corresponding homogeneous linear system. So null space is the set of all possible solutions of homogeneous linear systems. We'll discuss their dimensions and their basis vectors in the next lecture. I hope you would enjoy it. And we'll connect these concepts with the solutions of linear systems, both non-homogeneous and homogeneous linear systems.
Sir, I have a question about vector space proofs. So basically the 10th theorem that 1 dot v is equal to v, the existence of multiplicative identity. I wanted to ask that, is that 1 supposed to be unique, or can multiple multiplicative identities exist?
That 1 is unique, means 1 is a scalar in fact.
Yes, sir, but the thing is
But
that
But the nature of that vector can change. That vector, if v belongs to R2, then it is a vector from R2. If that v is from the set of polynomials, then it should be any particular polynomial which belongs to that vector space. Okay? That vector changes and the operations as well. The scalar and scalar multiplication operation it changes, or it depends what is the scalar multiplication operation is given along with that vector space set, which we need to apply on the elements of that set.
So इसी चीज पे मुझे मिड में थोड़ी सी कंफ्यूजन हो रही थी कि वेक्टर स्पेस से सिंगल एलिमेंट था और उसका स्केलर मल्टीप्लिकेशन डिफाइंड थी कि kx is equal to x. तो सर इसमें मुझे कंफ्यूजन थी कि अब आइडेंटिटी एलिमेंट अगर हम देखें तो k belong to r, every real number is an identity element क्योंकि kx is equal to x. So does that mean the 10th theorem holds, or does it not hold because there is no unique element per se?
No. In fact, more generally, if you look at that thing, k times some vector belongs to that space. That is a closure property for any value of k. But here in this property, you have to prove for a particular value of k. If k is chosen as 1, then 1 times v should be v. This is different from the closure property. In closure property, you just have to prove that if you multiply a vector by any scalar, it should belong to the same space. But here in this property, you have to prove that 1 times v should be equal to v.
Sir, how do you determine 1 in this case?
1 is 1.
So
One
just
doesn't change.
you just pick 1.
It depends on the scalars you are defining. But in your case, you are always taking scalars from the real number. So in real number, 1 remains 1 always.
So sir, vector space operation अगर change ना हो, यानी for all cases 1 will remain 1, basically जो मर्जी vector space हो.
In real numbers. If you are choosing the set of scalars from the real numbers.
Yes, sir.
Okay.
Right.
If you need to discuss these things further, you can ask me for a Zoom meeting. We can have a different, we can fix timing to discuss this issue if you have any further confusion. Okay?
Yes, sir.
Okay then guys, that's it for today. If you have any other question, you can ask me. Otherwise, I'm going to stop this meeting.